So, very welcome everyone to the SOILveR seminar, and the second in our series that we are calling On the Knowledge Road Towards the EU Soil Strategy and Law. And today's workshop is called Sustainable Land Use Beyond Agriculture and Forestry, and maybe that needs a little bit explanation why we call it Beyond Agriculture and Forestry. And actually that is due to that we have there have been several thoughts on the comments on the EU strategy and the discussions on the law that it is kind of founded in agricultural uses and forestry, and that it also concerns contaminated land, but that we would like to lift that there are so many aspects when we are remediating contaminated land that could actually also add or contribute to soil health. And we would like to lift that there is so much more within remediation of contaminated sites than just decontamination. My name is Yvonne Olsson. I'm part of the SOILveR network. I'm going to start by introducing you a little bit to what SOILveR is. But first, I think that everybody is already used to this, but please keep your microphone on mute, and you could also turn off your video. That might help your audio. And if you have any questions, feel free to use the chat. The SOILware platform is what we call a permanent platform. That is, it's not just a project, but it's ongoing. And we have two pillars that we're working on. We're working both on knowledge development and also on knowledge exchange. On the first pillar, we have had one pilot research call in 2019 and thinking about another one next year. We don't know yet for sure, but we will see. And we also have some other targeted actions with smaller budgets. The topics that we focus on are related to the EU soil strategy, and we try to have them in phase with the development of the soil health law. And we have already in our work touched upon several of the issues below that relate to the soil strategy, the new soil strategy. The knowledge exchange pillar that we're working on. We started, well, in 2019, I think, but we have been doing a lot of activities. We have, for example, have had exchanges on PFAS and one on lead, or both within SOILveR, but also in cooperation with, for example, Common Forum and IONET. We also started a series that we call coffee break meetings, where we have shorter presentations in specific topics of interest around contaminated sites. And now we have these seminar series, and the first stop, we call it, was on soil monitoring and schemes in several European countries, April 12th. And today we have this seminar. We are also planning for one. We hope to have one on June 30th, with a focus on soil passport and soil certificates, I think it will be. Today's program will be quite interesting because there will be so many aspects discussed around contaminated sites, and a lot on actually how to achieve sustainability in remediation and, for example, addressing biodiversity. I will not more go through the program, but we will continue. And I'll just say a few words on that. You are all free to contact us and to, for example, if you have ideas, on how we could maximize the cross-border collaborations and what our next steps could be. So we have a website and an email address. And if you would like to join us, we have a management paper on our webpage, and we have several kinds of memberships. You could be everything from a full member to actually an explorer to join us for a year without, well, actually paying any fees, because we have a small fee to join which is actually just a contribution to the secretariat fee. So feel free to look at our webpage and see if you would like to join us. We would like to have more members. And there, from there, we should move on to part 1 in the meeting. And we would like to invite Paul Bardos to give a keynote presentation on the importance of sustainable remediation in the new soil strategy. So please, Paul, welcome and give your presentation.
Thank you very much. Apologies to everybody that I'm a little bit slow with setting this up. Here we go. Can everybody see my presentation?
Yes, it's okay.
Thank you. So I'm going to try and relate the concept of sustainable remediation and then some thoughts about its importance to the new soil strategy in the EU. And I do hope that you'll forgive this presentation from an ex-EU member. I'd like to acknowledge my co-author, Nicola, and our contacts are there on the homepage. And these slides will be available as a PDF for SOILveR to publish. I'm going to begin with a short animation, and this will explain what we mean by sustainable remediation. This animation is free to access for anybody, and you're very welcome to share it.
Our industrial history has left behind a legacy of contaminated land and groundwater, which can present a risk to people and the environment. In some cases, the land remains in use, but in others, there is an opportunity for redevelopment. In either case, the risks from the contamination need to be managed, and this process is known as...
I'm sorry, I've made a mistake here. I was trying to make it go full screen.
Our industrial history has left behind a legacy of contaminated land and groundwater, which can present a risk to people and the environment. In some cases, the land remains in use, but in others, there is an opportunity for redevelopment. In either case, the risks from the contamination need to be managed, and this process is known as remediation. The technologies used in remediation have evolved over time, from simply removing the contaminated soil to landfill, or simply trying to pump out and treat contaminated groundwater, to more sophisticated and targeted solutions. However, even though it's done for good reasons, the process of remediation itself can have a negative impact on the environment and the surrounding community if not done well. So the focus has now shifted to encouraging stakeholder input into shaping a solution that avoids unacceptable environmental, social and economic impacts and seeks more positive outcomes. This concept is known as sustainable remediation. Sustainable remediation has 3 key elements: environmental, economic and social, which all need to be in balance and the impact of each considered. Overall, the goals of remediation must seek to protect human health and the wider environment. Any approach needs to be based on sound science, using clear evidence and a transparent decision-making process. The safety of workers and the general public must also be fully taken into account, along with the views of different stakeholders. To make these choices, we need a way to understand or assess sustainability. SOILveR UK has developed a guiding framework and a series of indicators which include environmental aspects encompassing soil, water and air, social aspects like the effect on health and communities, and economic aspects such as overall cost versus returns. Other effects that can be assessed include the impact on surrounding property values, be it detrimental or beneficial. It's also important to identify the circumstances that need to be considered in an assessment to ensure that options are compared on a like-for-like basis. Sometimes a solution can be shown to be sustainable using simple and basic methods of assessment. In other cases, a more complex assessment is needed. For this reason, a tiered approach is used, but always within the context and objectives set at the beginning. This begins as a qualitative approach and can become more quantitative if simpler approaches don't arrive at a clear answer. Greater gains can be achieved if sustainable remediation is considered early in the planning process, as this can affect the approach for different areas of the site, the risks to be managed, and the methods chosen to achieve a certain set of goals. SOILveR UK's framework for sustainable remediation and its supporting guidance is changing the face of remediation in the UK and helped shape a new ISO standard to support sustainable remediation around the world. For further information about SOILveR UK and sustainable remediation, visit www.clare.co.uk.
So that's our little animation, and that is pretty much what sustainable remediation is in a nutshell. So it follows on from the idea of risk-based land management, which I think is generally accepted across Europe now, which is that the risks from contamination are dependent on the linkage between a source, pathway, and the receptor. And you can deal with those risks in different places, either at the level of the source, through the pathway, or an intervention at the level of the receptor. And very common receptor intervention now is that we treat land for a particular end use, and then there's a planning control. And if the use of land changes to something that's more sensitive, then the risks have to be reevaluated. So we broaden that out by adding in the sustainability element. We broaden it out really in 4 ways that we're now interested to get an overall net benefit over and above the management of the risks, that we want to ensure a set of principles that lead to good practice for management throughout the whole site management process, to emphasize the need for engagement, to make transparent decisions, to make any sustainability assessment robust, i.e. because it's inclusive. And we also suspect that that inclusive engagement will reduce project risks, project challenges, because any red flags for people will already have been identified during the assessment process. And the final element of this, which is emerging in particular in the Nicole network, in the Netherlands and in the USA, is this idea of the stewardship of the land afterwards, so that outcomes are managed in the long term and are resilient. For example, resilient to processes related to climate change impacts. So if we're looking across the board at benefits of sustainable and risk-based land management, we can begin with the benefits of the risk-based component. So risk assessment provides us an objective understanding of likely harm. It also gives us this methodological framework and rationale for effective remediation, i.e. remediation that addresses risks. And it gives us the ability to prioritize our resources to the most significant and urgent problems. If we add in the sustainability component, then that allows us to optimize the risk management, for example, by better understanding and reducing any secondary impacts of the remediation process, by identifying whether there are wider benefits and greater value that can be achieved from the remediation, and therefore improving cost effectiveness. As I mentioned before, it's a useful process for identifying and avoiding project risks. We can use this as a process to document linkage to the UN Sustainability Development Goals, or indeed to national or local government policies for sustainable development, or indeed corporate policies. And we also firmly believe that for the organizations involved in sustainable and risk-based land management, this has a really positive impact on their brand. The animation emphasized the benefits of early sustainability assessment. This is a little model from the SURF UK Sustainable Remediation Framework. And on the right-hand side, you see this idea of choosing the most sustainable remediation tool. So on the right-hand side, we've already arrived at the risk management needs for the site. The risk management targets have been set. So we're making choices between different remediation options, for example, excavation and removal or a biopile, to find the most sustainable way of delivering these risk management goals. On the left-hand side is the early engagement. So in this case, we're using an understanding of remediation outcomes and design to actually influence the design of the project, whether it's for an operational site or a redevelopment site. Perhaps knowing what the impacts might be of a remediation, whether they're positive or negative, might influence our choices on how we use the land. For example, where we make a building area versus a garden area versus a parking area. In that way, we can get a greater sustainability gain because we can better target the remediation treatment to the problems that we need to deal with. Sustainable remediation isn't just a UK idea. In fact, the UK is one of many countries that's looking at this. And in this diagram, in the deep green, are countries where there's actually a specific sustainable remediation network in place. And in the light green are countries that are linked by a network, such as the Common Forum or Nicole, to sustainable remediation. And I guess we need a new color for the Netherlands, which is perhaps seeing itself in a post-sustainable remediation world, where it's looking at the broader context of better soil management. Just as we have achieved for risk-based land management, there's an international consensus really on sustainable remediation, which is exemplified in this standard, which was published in December 2017. And although the states are not in ISO, there is a related ASTM standard on green and sustainable remediation. The ISO is available in 2 languages, in English and in French. And I'm reliably told by an Australian colleague that if you buy it from the Australian standards organization, it's a lot cheaper than buying it directly from ISO. So how does this link to the European soil strategy? Well, the soil strategy is setting out a framework and concrete measures to protect and improve soils and ensure that they're used sustainably. and it set out a vision and objectives to achieve these goals, to achieve some kind of legal framework by 2050 and concrete actions by 2030. Now, there was a problem that you all know about with the previous Soils Directive. It was put forward by the European Commission, and 4 or 5 countries blocked it because they felt it was not aligned very well with best practice in sustainable and risk-based land management. While the Common Forum did offer a compromise text that would have gone forward, the Commission felt that that wasn't ambitious enough, so the directive was put away for the future. So now we have the emergence of a new Soils Directive or Soils Health Law being put forward. How can this idea of sustainable and risk-based land management assist that development? Well, the first thing that I want to mention is that the European Soil Strategy's key actions, as published, already have a very close linkage to sustainable remediation. So in terms of soil health and achieving good soil health by 2050, then my contention would be that sustainable and risk-based land management is the optimal approach for this, at least for legacy issues, by which I mean historic sites. It talks about making sustainable soil management the new normal, and for land contamination and brownfields, sustainable and risk-based land management is already becoming the normal. Maybe this offers lessons for other soil contexts within the broader range of interests that SOILveR has. The soil strategy points out the particular opportunities for better management of wetlands and organic soils and peatlands in terms of climate change mitigation. I would add to that, don't forget the contribution for climate change mitigation and greenhouse gas mitigation from the better management of land contamination. And also, of course, this increasing recognition that our remediation needs to be resilient to climate change in the future. The strategy sets out an ambition to create a soil passport for the circular economy. Well, this is already aligned with the ideas of most of these sustainable remediation fora. There are already examples of applying sustainability principles for soil, excavated soil management, for example, in Belgium, the Netherlands, UK, and possibly elsewhere. The soil strategy points out the need to restore degraded soils and remediate contaminated sites. So I repeat that sustainable and risk-based land management is the optimal approach for doing this. I even suggest there's a linkage to the interest in the soil strategy of preventing desertification. Perhaps there's some lessons to be learned from the process by which this consensus on sustainable and risk-based land management was reached. And it was reached in large part because we have very good communications between stakeholders and countries in Europe, for example, through the Common Forum and through Nicole. Obviously, improving soil research, data and monitoring allows for yet better optimization of land management and better decision making. And finally, in terms of this last ambition of mobilizing engagement of society and financial resources, I think sustainable remediation gives a platform for a transparent approach for engagement of society and a transparent approach for the valuation of wider sustainability benefits and impacts. Sorry, there's quite a lot of talking on this slide. For SURF UK, it looks at the scope of sustainability across 5 headlines in each of the 3 elements of sustainability. And it's quite deliberate that we've chosen 5 because we want to emphasize it as a balanced configuration. And this links directly to the question of soil health. Just for your information, there are many approaches and tools developed for sustainable remediation around the world. So this is the information map from SURF UK, but there is information from SURF in the States and from many of the other SURFs around the world, which are generally freely accessible. One thing that you might have heard about is that there are a number of different terms. So there's a term called green remediation, a term called sustainable remediation, something called green and sustainable remediation, and now something called green, sustainable and resilient remediation. So green remediation comes directly from the political context in the USA. So it comes from an ambition to improve the environmental performance of remediation on Superfund sites, and it assumes that the economic and social part of sustainability has already been addressed earlier in the decision-making process. And you'll see that the elements that are in green remediation very closely align with SURF UK's view of the elements in the environmental segment of sustainable remediation. In terms of green and sustainable remediation, this is a bit of a fudge that was developed in the States because there was quite a lot of contention between people who were following green remediation, mainly led by the EPA and different federal interests, and from state level and private sector interests who felt that for their sites, they needed to have a more holistic sustainability approach. So in the States now, this term green and sustainable remediation exists as a kind of a wraparound to say that all of these things are good and part of a single whole. China has adopted this idea of green and sustainable remediation. I work in China quite a lot. I don't think they're fully taking on board that it is actually a product of the particular regulatory and policy context in the States. I think in China, they like to use the words green and sustainable remediation because they have a stronger drive from their government to mitigate secondary emissions and deal with carbon rather than to mitigate societal and economic issues related to remediation. So this is why they're picking that term. And then there's this new idea of resilient remediation, and this has been driven in particular by discussion in the States, where there's a lot of concern that the impacts of climate change, including on flooding events and things like this, means that remediation solutions are challenged or may fail. So there's great interest there in having remediation that's resilient to these impacts of climate change. And in SURF UK's world, the idea of resiliency and soil stewardship fits into this group of indicators. So I have got some extra slides in case there's time available, but I was anxious to keep things short. So these are my conclusions in terms of research needs that perhaps SOILveR might want to consider. The first is a positive, which is to say that sustainable remediation is well developed and part of a global consensus along with risk-based decision making. And I think that it's well aligned with the goals of the EU's soil strategy. Taking those 2 points into account, I think the research needs to take this further, in particular, is to elaborate more case studies and real-world applications. So there is a project being undertaken by the European Network on Kawi, which will release about 10 sustainable remediation case studies, but actually these case studies are in short supply. Something else that we don't really know about is we might make a sustainable remediation assessment and pick a remediation approach that we think is most sustainable, but we don't have any long-term validation of those sustainability outcomes. So we don't know if the outcome of our choice was really what we hoped for. Something else that is probably a missing area is in terms of valuation, which is to be able to reliably link some of the broad interests in sustainable remediation with some idea of cost effectiveness, because this is often what is driving the remediation decision. Fourth area is this idea of big data, whether it's possible to consolidate information across many sites to give us a better idea of what the sustainability drivers might be for contaminated sites management. And finally, we only have limited experience of stakeholder engagement of different kinds and whether we can improve those engagement processes. Yvonne, Ingrid, I can stop here. I've got a couple more slides. It depends on what you would like me to do, or whether you would like, or whether this is enough to start a discussion.
Well, there's 10 minutes Q&A session available. So if anybody has a question, please post it in the chat or raise your hand.
So I'm Marie Jaillet. I'm going to exchange for the question and answer. I see that there is no question at the moment in the chat. So I'm Marie Jaillet and I am full member of SOILveR. I work in SPAC, which is a company in charge of the remediation of orphan sites in Belgium. I'm very interested in your presentation, Paul Bardos. And I agree with the sustainable remediation, which is necessary when we have very large, big polluted sites, because for the money and for the economic way, it's not possible without sustainable remediation. So remediation based on the risk assessment is now very habit. So I agree with you, and I agree with the European soil strategy, which is very in the same way as a sustainable remediation. For example, with not net land tech, with not concrete first. So for the remediation works, I think that we know how to do a sustainable remediation, but for the redevelopment project, I have a question for the redevelopment project. How do you see a sustainable remediation when you talk about economic and social aspects in a redevelopment project?
I think that's a really interesting question. By the way, there are also sustainable remediation tools that work for small sites, which are maybe worth considering. So for this question about the large site, I think that there's obviously a lot of tools that exist for sustainable construction. So I think in this situation, there's perhaps an applied research need, which is to link the sustainable remediation world with the sustainable construction world. But there are also other sites, of course, which are quite which we don't develop for built use, which we develop for public amenity or for habitat. And I think for these sites, the tool sets that are existing now from the Sustainable Remediation Fora, I think they're very useful. There is a Framework 7 project that I was involved with called Ombre, which started to develop this idea of linking sustainable remediation with long-term management of these soft reused sites. I think what you're talking about is really also very much in line with the way that things are being seen in the Netherlands and the way that Nicole wants to take the discussion for sustainable remediation towards a bigger discussion on land stewardship. I think that there's no obstacle to having a single sustainability assessment approach that describes both the restoration of land and the use of the land. And I think that some of your colleagues in SPAC have already had a look at that for landfills under the Interreg project that you did. But I think that those are really good questions. And I think that would be a great thing for SOILveR to promote, would be this integration of the reuse and the remediation to make a sustainable future for the stewardship of land into the future.
Into the future, okay.
So, thank you.
Thank you. Is there anyone someone has a question for Paul Bardos?
Maybe I have a question for everybody else. I'm very interested to know how far does this talk that I gave actually fit in the SOILveR world? I mean, how close is it to everybody's interests? I'd be interested if some of the people here could give me a view on that, because maybe it's very much in your interest, or maybe
Yes, maybe I should comment on that. This is Yvonne again. Yeah, I think it is. It's perfectly in line, and I think also that well, you mentioned that this is already accepted methods in large parts of the world, but we see that in several countries we actually need examples, experiences. So I think this is very good input for all of us. One experience that I would ask you if you recognize this. We have sometimes seen that there is a kind of a misunderstanding on what sustainable remediation is, and that for example, that you mix up. I mean, when you do your risk assessment and you set your remediation goals, etc., and then you should also weigh in the costs and potential to do things, etc., all other aspects. Then that it's kind of sometimes that you're saying that, oh, it's too expensive to remediate, so we accept more risk. And then we get into a discussion on, well, leaving, how do you say, leaving risk that we weren't actually planning to accept. But instead of addressing several ways of reaching the goals and choosing the more sustainable way. Do you understand what
I understand exactly what you're saying, and this was one of the main points of dispute between the US EPA and SURF in the USA. So the regulators felt that industry was trying to trade sustainability for risk protection, levels of risk protection. And this has also emerged in discussions in the Common Forum, that regulators have felt that is this sustainable remediation something from industry to get away with a lower quality of risk management? And I have a categorical answer, which is no, it's not. That's not the intention. So for SOILVE UK, it's clear in all of its publications that achieving acceptable risk management is the underpinning of the remediation process. I mean, that's the reason you're doing the remediation in the first place, is to manage risks. So if you then don't manage those risks, you haven't really completed a remediation. So I think the two ideas are completely aligned, and what we're trying to do is optimize the process of risk management. Now, this gets a bit tricky when you're looking at planning the site configuration. So this early consideration, where you might, for example, decide to move the location of where your car park is going to be because you can manage the risks better by containment and more sustainably by containment than digging the ground up, then I would accept that there's some kind of trade-offs going on there, but they're not at the expense of the overall outcomes for the receptor. They're kind of just trying to reduce the inputs that are necessary to getting a protective risk management for all of the receptors. Does that make sense, Yvonne?
Yes, I think it does, and I think that, well, it was very clear in your presentation where in the phase that you do the weighing between well, these different aspects of sustainability. So I think that's very clear, and I think it will contribute to I mean, this framework will contribute to a lot of countries' maybe ways of communicating. So I think it's very helpful what you presented. Really good.
Thank you.
There are some questions in the chat. For example, what is the important criteria for such a sustainable remediation? But there is the time for the second presentation. So I don't know if we keep the questions for the end, or you prefer to.
There is, these criteria vary from site to site, and we in the UK, we have a checklist which is on the on the SOILVE UK website there, which you can look at, and there's some discussion of that in the slides later on, so you'll be able to download these slides, and that addresses your question a little bit. If you want to know more, Marie and Ingrid will put you in touch with me, I'm sure.
Okay, thank you very much for your presentation and the discussion. And now we can go on with the part 2 of this workshop. The part 2 will be about the biodiversity and the importance of taking into account the biodiversity during the remediation works or during the redevelopment project on a site, which is not done every day today. So we can start with a presentation of Björn Johansson, who works at Naturvårdsverket and is going to explain the enhancement in the recovery of ecosystems. Björn Johansson works at Naturvårdsverket, which is a Swedish agency for the protection of environment. And he works about the development of new technologies in the remediation field. So thank you for starting your presentation.
Hello, and thank you very much for allowing me to participate in this seminar. I will try to get this go. Can you see my slide here?
Yeah.
Yeah, so I'm Björn Johansson, and I work for the Swedish Environmental Protection Agency, or Naturvårdsverket, and I will try to talk about how we aim to develop promotion of biodiversity and remedial projects financed with government funds. And as a short background towards to explain how we finance remedial actions where there are no responsible party. I will start a slide and let's start it over again. Yes, so we have a couple of drivers in Sweden where the most important is our environmental code that which is based on the principle of that the polluter pays, and we've had this legislation or versions of it since 1969, and we also have a number of environmental quality objectives that we consider are in line with the Sustainable Development Goals, and the one that is most related to contaminated land remediation is a non-toxic environment, but remediation and taking care of legacy pollution is much more the cause of why we're doing that is to achieve our other objectives, which include biological diversity and sound living streams and the water courses and groundwater with good quality, etc. So in order to reach those objectives, we need to manage our contaminated sites. And as I said, the main principle is that the polluter should pay for the cleanup that is necessary to achieve those goals. But since we have a long industrial history, there are a lot of contaminated sites now where it's not possible to make the polluter pay. Either they don't exist anymore or the contamination occurred before there was a valid environmental law. So therefore we have government funding to finance those cleanups, and our funds is approximately 90 million euros annually, and the last couple of years it's been increasing. So what we try to do is use that money to create the most environmental benefits that we can, and to manage our historical legacy. But the main objective is to remediate contaminated sites and remove risks and contaminants related to that. But historically, where we do finance, have financed a broader spectrum of post-remedial treatment, in lack of better word, that goes beyond the actual decontamination or risk management. But in about 2020, the EU Commission started an audit on the funding system, and in relation to regulation on state aids, the GBER. And because of that audit, which was finished late last year, during that time, we have been forced to enforce a more strict interpretation of the ordinance that governs the state funding. And so that our interpretation has been that the money can only be used to remove the risks or contaminants, and there's been a very little room for restoration activities and preservation of natural and cultural heritage. But as of April this year, we have 2 new ordinances governing our funds, and there is one that is aims at state grants, which covers remediations where there are no economic economic operations connected to the property ownership. And with that new ordinance, we do have a possibility to finance a certain restoration activities beyond the contaminant and risk reduction. And then we also have a new ordinance governing those cases where it's state aid. That is when there is an economic activity or operation connected to the property ownership. So so the ordinance says that grants may be given for actions that are required in order to preserve or restore natural or cultural values related to remedial actions, providing certain conditions, but it does not specify what conditions those are. So what we aim to do this year is to find a way to maximize the environmental benefits from having our state these fundings, because we see that by remedial actions and our funding system can function as a lever for much larger added values than only risk and contaminant reduction. And by quite limited efforts and not very costly actions, we can enhance recovery of the ecosystems where all the industries have been, and to contribute to more environmental quality objectives and sustainable development goals. And but we need to consider that the main objective of our money is to remediate contaminated sites, but we need to find a proportionate way forward in what is reasonable for the government to finance to stimulate biological biodiversity. Sorry. And but with the part that is the state aid, which I believe will constitute the majority of the contaminated sites, there are limited possibilities to finance these kinds of activities. But we expect new regulation and a new version of the GBER rules that may give, as part of the Green Deal, that may provide better possibilities to do so. So this year we will work together with interested stakeholders in the government funding scheme to provide guidance on what constitutes certain conditions. That is, when can we finance these restoration activities beyond contaminated removal, in order to get find a proportionate part. The restoration activities needs to be in proportion to the objectives of the funding, so to speak, but to create the most added value we reasonably can with this funding we have as an instrument. And we will also develop or compile guidance on preservation and restoration activities connected to remediation of contaminated lands, saying what, like exemplifying what activities could be done to stimulate pollinators and make other different kinds of activities to improve the biological biodiversity. And I've not focused on it, but the possibility is also to preserve cultural heritage that is not directly related to the remediations, because these sites are oftentimes culturally valuable, saying a lot about our the development of our society. So I hope that after this year and the forthcoming use of our money, we will create added values for biodiversity and also all other environmental objectives as climate change mitigation and adaptation and so forth. And Helena, who will speak after me, she will talk about a project that has been financed by us, but before the work that I've described now, but her case is an inspiration for our development going forward. So thank you for me.
Thank you for your presentation. I don't see questions in the chat about this presentation, but I have one question.
Yes.
So Ferry, thank you for your presentation, and I'm very interested in this case of having some money to do remediation works for orphan sites, for abandoned sites. Yes.
Yeah.
I have a question. Do you have the power on the redevelopment project to put the biodiversity in the project, to add this?
In redevelopment projects, well, not real. Well, not connected to these this funding, I don't think. But there are other tools, I believe. But that has a lot to do with a field that I'm not an expert in, that like in city planning, etc. Which requirements you can what you can require by the developer in how the actual future land use will what that will look like. But I think there is a need to connect the city planning with the remedial community and regulation to get a joint solution.
Yeah.
Both addressing historical land use and future land use at the same time.
Yes. There was a very positive. There is a question. I don't know if you can read the chat, but there is a question for you. Will the new state grants and the aid be primarily aimed towards high risk priority sites, risk class 1 and 2, or with lower risk sites that enable gentle remediation option also be eligible for such funding?
Well, no, in Sweden we have a priority system called that is based on 4 different risk classes, and within the government funding scheme we have prioritized to work with the most highest risk sites. So it will still be the risk class 1 and 2 that is the objective, and these biodiversity enhancement activities, I don't have a good English name for them, but those needs to be connected to those remediations, and it will not be possible for us to finance those kinds of activities generally unless they are connected to a remediation of such sites. But there are other grants for those purposes.
Okay. So is there other question for Björn, or we can go on the next presentation? Okay, it seems okay. So now we are going to go on with the presentation of Elena first, who works in WSP, which is a consultant specialized in contaminated sites. So we are very happy, and you are going to explain how to take into account this biodiversity during the remediation and the development project. So thank you, and you can go on. Start.
Yeah, thank you very much. I think you see my screen now. So biodiversity and thus the basis of life on Earth is threatened. Up to 1 million out of about 8 million known plant and animal species risk disappearing within a decade. Deteriorating biodiversity leads to deteriorating and disappearing ecosystem services, which is crucial, for example, for the human food supply. And therefore efforts are needed in many areas. And my presentation is about how to take natural values and biodiversity, how it can be considered in the work with contaminated areas. So how does old industry affect? In the 1970s and 1980s, the sea eagle population in the Baltic Sea was nearly being wiped out due to DDT and PCB. Overexploitation of land and water, climate change and pollution are some of the reasons for rapidly declining biodiversity. To the left in the picture, you see Brandsnäs sawmill, still in operation in 1954. And in the aerial photo to the right, the cleared ground can be seen during the closure around 1960. And the cleared land around the sawmill affected, among other things, the green infrastructure. In the northern part of Brandsnäs former sawmill area, there is a value network for deciduous trees. And value networks mean that the area where there are higher natural values than in surrounding land, that they are so close to each other in the landscape that there is an ecological exchange. And these value networks are an important link in the green infrastructure, but they are also vulnerable to exploitation. So, but at the same time, the value networks have a great potential to develop towards greater natural values in the long run. For about 40 years, wood was impregnated with pentachlorophenol product, which also contained dioxin at the sawmill area. And this place is located on a peninsula in a larger lake in southern Sweden. And dioxin binds to soil particles and breaks down very slowly. And were therefore the pollution that remained in the soil more than 50 years later when the site was identified as a suspected contaminated area by the county administrative board. The properties of dioxin, together with the fact that there were recreational houses in the area, also forced us to choose excavation as remedial measure. And basically the whole area was going to be digged up. Investigations and remediation measures have been carried out with state funds, as Björn mentioned, in the absence of a responsible operator. And this project with the Swedish Geological Survey as project leader and WSP as consultants. We got some inspiration from our colleagues in UK, WSP in UK, and learned that a new environmental bill, or new at least in 2020 in England, there was a new environmental bill making biodiversity net gain mandatory in new development projects. And this, together with the tool that WSP in UK had developed about finding the biodiversity net gain in the redeveloping projects. As you can see in the picture, it could be net loss or no net loss or a net gain. And this, together with a picturesque site at the sawmill, the former sawmill, it inspired us to suggest to the client to take biodiversity into account in the remediation project. And they were positive and ordered an inventory of natural values as a start. And the inventory, or what we did, was to combine expertise in contaminated soil and ecology. And my colleagues in ecology, they did an inventory of natural values and also about, of the potential to enhance the natural environment. And then we took in the information in the evaluation criteria when choosing remedial measures. And later, we also took biodiversity into account in the restoration plan. From the inventory, not very surprisingly, we hadn't great natural values in general, and no classification was made at all in large parts of the area due to human impact and therefore a young natural environment. But some significant natural values they found positive for biological diversity in 2 areas. The first one, it was an older broad-crowned and sunlit pines with conditions for species diversity. And the second one in the central part of the area was a shore environment with values for biological diversity in the transition zone between terrestrial and limnic environment. In addition to the current situation regarding natural values, it also became important for the project with what potential there was for strengthening the natural environment, which was also assessed in the inventory. We could preserve coarser trees, we could promote the development of pine and oak tree crowns through careful thinning. We could create a valuable forest edge environment along the road by conserving young oaks. And in the long run, this would strengthen the previously mentioned value network for deciduous trees in the area. And this is the restoration plan we did for the contractor, showing where we wanted biotope structures after finishing the excavation or the remediation. Biotope structures like deadwood, boulders, pine trunks in sunny spots, and also where to seed dry and damp parts into a meadow, and also preservation of valuable trees and group of trees. For example, the smaller oaks along the road, as I mentioned. Well, with the pollution situation that was, and not least along the shore area within the central sawmill area that had been pointed out with a significant natural value, the question was whether it would be possible to avoid destroying it all and instead preserve the current natural values. And this is how we did it. The dioxin contamination would lead to vast excavation. So in the beginning of the remediation measures, of the remediation measures, we did risk calculations of how much soil we could leave without an unacceptable health risk. And by doing this, we could leave some amount of contaminated soil below a maximum dioxin concentration set at the level where single intakes of soil could give unacceptable risks. And the calculations told us that we could save up to 10% of the soil in the area, which meant about 1,000 cubic meters, as long as we removed concentrations above 1,500 nanogram dioxin per kilogram soil. And thanks to this approach, we could save both natural and recreational areas, and this including the valuable part of the shore. And then during the remediation, as you see on the picture, we continuously followed up the volumes and the concentrations by sampling all soil that was intended to be left. And this to avoid exceeding the maximum levels, both volumes and concentrations. And then in the end of the remediation, we did new risk calculations on actual data to ensure that the remedial goal was fulfilled. That's the contribution to the tolerable daily intake from dioxin in the area should be less than 10%, and it turned out to be the fact. Finally, some pictures of the added ecological values. We'll see to create a dry and wet meadow. We preserved the young oaks along the road, and the contractor created some biotope structures to support insects. And by that, I hope that I have inspired to take natural values and biodiversity into account also when it comes to remediate contaminated land, and it's a very small cost in the context. Thank you for listening.
Thank you very much, Elena. We have a question from Paul Bardos about the tool, the WSP tool. It is available for all users, or
I'm not sure about that. I have to refer to my colleagues from UK, but I think it's a WSP tool that we use in our projects and offer to our clients.
And can you tell me the name of the act that you mentioned? Richard thinks it's Environment Act 2021. I'd be really interested to know, because there's some people who want to...
I can try to check it up during the meeting here and put it in the chat.
Fantastic, thank you.
I'll try, yeah.
did you consider other remediation alternatives than excavation for managing the dioxin? It is a question for Paul Drinning. So when you do the excavation of dioxin, for the dioxin, do you think about another alternative, another remediation, kinds of remediation?
Yeah, it was a bit special on this project. Of course, we do that in when trying to find the best remediation measure. But as I very shortly mentioned, it was very high levels, high concentrations of dioxin in the surface and the surface soil, and several recreational houses and camping site in the area. And dioxin is quite hard to treat. So the soil had to leave the site. That was the only option. So what we looked into instead was different was different options on how much soil that was to be excavated, and we landed in leaving contaminated soil from 1 meter below the surface, the ground. So it was an excavation, the first meter in some parts of the, or quite a lot of parts in the area, it was quite close to the bedrock here. But in some parts we had to leave contaminated soil, and we did, but we didn't leave soil above this risk level of 1500 nanogram per kilogram.
Is there other question for Elena? So I have a question. For one hand, you talk about the WSP tool for ecosystems, for biodiversity, and in another hand, you talk about the risk calculation you did for the recreational land use, but it is a risk calculation for human health or risk calculation for biodiversity?
No, that was risk calculations for human health. It's
human health. Okay.
Yeah.
Because your tool is not a quantitative risk.
The tool is the tool is just for biodiversity net gain, and it's used in like redevelopment projects normally, I guess. So it was more that I got inspired of the fact that we had such a tool, but we normally don't use it in. And I think we tried it in Sweden, but not on contaminated land. So it was just the thinking to not end with the net loss and hopefully a net gain, but at least not a net loss, even in contaminated land, and even when we have to excavate a lot of soil.
Okay. So, are there other questions for Helena? Because we are on time. No, so thank you very much, Helena.
Thank you.
So now we can go on with the next presentation. Welcome to Geoffroy Serret, working at the University of Lorraine, and is going to talk about the review of the last 2 decades of Technosol construction for urban greening. So you can start your presentation. Thank you very much.
You're welcome. Good afternoon. Can you hear me correctly and see my screen? Great. So this is a great pleasure for me to be here to present indeed some of the work we did about a topic which is slightly different from the ones that have been presented before. As you will see that we didn't focus on remediation of contaminated soils, but let's say reclamation of degraded soil, mostly because of a lack of fertility. And we will also move to urban areas, more within the cities. And I will present on behalf of my co-authors from different countries, France, US, Russia, a review of the last 2 decades experiences of Technosol's construction for urban greening. I guess that maybe this you might not be so familiar with the topic, so I will briefly introduce it. I guess that all of you are aware of the fact that there is a rise in urban population. Nowadays, there are more than half of the world's population that live in urban areas, leading to a coverage of urban areas of more than 3% of the total world land areas. And at last, this soil artificialization leading to impervious areas is still increasing over time. Let's say, as a consequence of this soil artificialization, of urban sprawl, there are many environmental issues that are specifically concentrated in urban areas. Just let's mention urban heat island, because of a lack of transpiration and of a quite due to the albedo of the materials used in our cities. There are also issues related to urban water cycles, floodings, like a lack of infiltration and in the groundwater. One of the answers to tackle such issues are the implementation of vegetation, greening our cities. You probably also know that green infrastructures can be defined as interconnected urban spaces that could provide multi-ecological functions. And of course, such green infrastructures can be part of the solution to tackle these issues. But of course, and I guess that as soil scientists, you're aware of that as well, such green infrastructures mainly rely on functional soils component. Unfortunately, urban environment is not really optimal for vegetation development. Let's say that anthropogenic activities very often lead to the degradation of the urban soil's quality, leading to soils that are with a very low fertility. In addition, this urban environment is really not appropriate for the development of vegetation, and the cohabitation between urban infrastructures and vegetation is really tough. As a consequence, in order to revegetate the cities, we mostly excavate the in-situ urban soils. I guess that you all experience such such a situation as the ones that I showed with this picture. We excavate the in situ urban soils, and then we replace it by natural topsoils that have been scrapped and then transported to green the cities. We did an estimation of this use of natural topsoils in France, which is more than 3 million tons per year. I assume that you can guess easily that such practice has a massive and very negative impact on the environment. And also we could consider that it has an increasing cost due to the diminution, the decrease of the availability of such resource as natural topsoils. In order to find a solution, we developed this, let's say, process of constructed technosols that I will explain later. But just to describe the context, the idea is to promote circular economy for urban greening. Let me put it, let's say, a very simple way. Right now, the situation is that we are importing raw materials from rural area, both for construction, wood, bricks, metals, and so on. But we are also, as I just explained, importing materials from rural areas, such as topsoil, peat, for example, in order to green our cities. Then, due to the activities in our cities, we are producing some wastes that are then later on exported to rural areas. Waste coming from human activities, but also coming from city activities, earthwork, demolition, but also, of course, the green, the management of these green areas. When we are, green waste comes from the grass cuttings and tree cuttings. And very often they can be composted, for example, outside of our cities. Our idea is quite simple, is to reduce the importation of raw materials, especially the ones that could be used, that are used to green the cities, and to recycle, to reuse the waste and byproducts from our anthropogenic, from our city activities, in order to green them. So what is the principle of the construction of Technosol? Technosol is the term used to describe, after the WRB, to describe soils with a very large influence of human activities on them. If you want to construct a Technosol, the beginning of the story is quite simply, you had at the beginning natural soils that has been degraded by anthropogenic activities. After, for example, remediation approach that have been described by the previous speakers, you could later on have a soil with still quite a low fertility, for example. In this case, you could consider to create a new soil, but not by using natural resources such as peat or topsoil, but by recycling waste or byproducts. And then you could create a new soil layer by layer, horizon by horizon, also by mimicking the natural organization of soils in order to promote the development of vegetation. As I will later on explain, one of the, let's say, the advantage of such approach is that you could adapt the formulation, the recipe, let's say, like when you are cooking, you can adapt the recipe of these constructed technosols to the future land uses. Indeed, and this is the very first step in this approach of creating new soil, you have to design, to define what would be the ideal soil for each land use. This is quite obvious, but of course, the optimal soil to promote a grassland is a different soil from the optimal soil to promote the development of a tree in a city, or to produce some tomato, for example. Each time you can define what could be the optimal soil for each land use. So this is the first step. Then, but I won't go too much into detail, the idea is really to adapt the properties of the soil to the, let's say, the requirements in terms of fertility, water infiltration, but also human health, as again, also it's been mentioned by the previous colleagues. Then, and I will just give a very brief example that I will later on explain. I asked we defined what would be the optimal parameters in terms of pH, nitrogen, phosphorus, and so on, for in order to cultivate some hemp. And in this case, you can, for each land use, define the best soil as possible. This is the first step. Then the second step, of course, is to identify deposits of waste and byproducts that are available locally. Just a few examples that we used for in various projects: compost, both green waste compost or sewage sludge mixed with green waste compost. We could also use sawdust, peppermill sludge, sediment, red sediment, ballast from railroads, or even brick waste. Third step is to define the recipe, to define the optimal formulation. The idea is to define how and what types of waste and byproducts we could mix together in order to reach properties that could be as close as possible to the one that is expected from step number 1. We defined some experiments to do that, and also a modeling approach, which is still on its way. And we also have to, from a very practical point of view, we also have to define a procedure to mix and implement the mixtures depending on the scale of the plots to reclaim, for example. This is the approach. And now let's move to a few examples of results in various contexts of this construction of Technosol. Let's start with Carbon Sponge, an initiative from our colleagues in New York, in Brooklyn. They created more or less a living lab in order to create constructed technosols with local inhabitants by using waste such as compost or soil materials, but from deeper horizons, or also some sawdust, for example. And their idea was really to promote both urban design, as you can see, but also carbon sequestration due to the properties of such technosols. A second example, coming from a project that was conducted in France, which is called CITER, that was funded by the by the French Environmental Agency, ADEME. The aim in this project was to recycle urban waste in order to create technosols for urban greening. In this case, we created technosols to promote the development of urban trees. We tasted various recipes, one control, one with a mixture between bricks and compost, and other waste such as ballast from railroads, sewage sludge, and deep soil horizons, and another technosols with demolition rubbles. You can see here, I won't go too much into details, the biomass production depending on the treatment. And in fact, we had a better production of biomass from trees with the constructed technosols than with the control. A third example, coming from a work performed by our colleagues in Angers in France, in collaboration with EDF company, that aims at recycling hydraulic dam sediments into constructed technosols, so to mix them with various wastes and byproducts in order to promote greening. And they did tests both on a greenhouse and also on the field, and they really succeeded of integrating these sediments with other waste in order to promote greening of derelict sites. And a very last example funded by a European agency, which is called SOILveR. We also aimed at creating technosols, but in this case, in order to produce non-food biomass. You can see here the demonstration plot installation. We created 3 hectares of constructed technosols. Here is one treatment with a biotreated, bioremediated soil mixed with compost, another layer mixed with dredge sediments, and a last horizon with a mixture between sediments and peppermill sludge. And we succeeded in cultivating some hemp in order to produce some fibers. And the next year, we also produced some wheat for biomass, energy biomass. So to conclude, so constructed technosols are, of course, artificial soils that are 100% made of artifacts of the WRB, especially waste and byproducts. They can be implemented as substitutes to natural resources for urban greening or for greening of urban industrial wasteland, for example. They are capable to provide multiple ecosystem services in a similar way to natural soils. But I won't go too much into details because this is one of my research topics. Such constructed technosols are also submitted to a very fast and intense early pedogenesis, which is of high interest for soil scientists. So thank you very much for your attention. And if you're interested in such topic, you could would be happy to have you during the next SUTMA conference. SUTMA means Soils of Urban, Industrial, Traffic, Mining, and Military Areas, that will take place in Berlin in September. Thank you for your attention.
Thank you very much, Geoffroy. We have two questions in the chat for you.
Okay.
I suggest to take this question before going to the next presentation. So
okay.
The first question is from Daniel Ritz. Isn't it better to adapt the function to the intrinsic properties of the soil?
That's a nice question. And of course, this is what we usually do for agriculture or forest. Of course, you select a crop that is adapted to your soil, or you may slightly modify, improve the soil to fit to your crop. But in this case, as we are starting from zero, we are creating a whole soil. It is possible to specifically adapt the soil to the requirements, the land use. But of course, it has to be adapted.
Okay. And the second question is, where do you go to the supermarket to get the soil? You need the materials. Is there an exchange platform for the waste and materials you need? How do you?
Yeah. Thanks, Julie, for the question. I would love to have an exchange platform to have access to a whole different types of waste. This is a specific job, and in fact, we are working with companies in France that are dedicated to the management of waste. And this is not easy, as some companies are more dedicated to organic waste, some are more dedicated to mineral waste, and it is, to be honest, not easy to choose and to select the appropriate deposit or to identify them in a proper way. But I know that in the Netherlands or in Belgium, it's much, I would say, I bet it would be easier, as you are much more well organized to do such market exchange.
Okay. There is a question from Richard Lord. How do you encourage the users to choose a recycled soil product compared to natural?
Thanks for the question, Richard. Two good reasons, I would say. I didn't mention, but of course, our recommendation is to use waste and byproducts with a very low level of contamination. Of course, as we are using them for urban greening. And why could it be relevant to consider? First, from an economical point of view, because I don't know what is the situation in the other European countries, but in France, the cost of natural topsoil is continuously increasing. And now it reaches, depending on the region, around 30 euros per ton. So it is quite expensive. Whereas on the other way, if you're recycling waste, you can have the waste sometimes for zero, or in certain cases, for example, paper mill sludge, the producer can pay you, can give you some money to recycle it. And the second aspect, for local municipality, the interest could be also to recycle for their own for the internal use, the waste, for example, to recycle the green waste, they don't have to pay to recycle it, and they can directly use it. And maybe I don't want to take too much time, but Paul is absolutely right. There are many regulation issues, even in France. And this is, as a researcher, I'm more dedicated to the development of such practices, but there are many regulation issues. And we are, for now, there are two options. One is to have a dedicated platform that could prepare such mixture and then use it on specific site. The other alternative is if you use it to reclaim, for example, a brownfield, you can have a specific authorization to conduct such approach on a dedicated part of the site.
Thank you very much, Geoffroy.
You're welcome.
Now we can go on with the next presentation. We stay in France and we go with the presentation of Julie Estival. Julie Estival is an engineer in agronomy working in TO. TO is a service provider in France and in the other countries. And she's going to explain the interest and the advantages of the phytoremediation. So thank you very much. You can start your presentation.
Yeah, thank you, Mary. So do you see my screen and my presentation? Good.
Yes.
So I will present you a case in France where we used phytoremediation to treat the soil contaminated with hydrocarbons. To tell you a little bit more about the context, we are in the southwest of France, and the site is contaminated with oil, with drilling mud that has been used to drill some petroleum drillings. And so the soil, the mud is contaminated, highly contaminated with hydrocarbons, and it represents a very large volume because we have as much as 16,000 cubic meters stored at this site. So the contaminated soil has been packed into open pits in soil that has naturally some clay in it, so it's more or less contaminated. Soil is confined in this at this site, and also a clay layer has been put on top of it to protect it from rainwater. So you have to know that at this site we are in a really remote location. It's a very rural area with lots of fields and forest and stuff, but no main roads, no water or electricity. So of course it's a real problem for remediation. We cannot use standard techniques such as excavation or thermal treatment or whatever. So we chose to focus on soft remediation techniques such as the bioremediation and phytoremediation. The good point was that we had no time constraint, and the goal behind all the remediation process was to restore the former use of the land, that is to say agriculture. So the goals for the remediation were to, of course, achieve pollution abatement, to limit installation and operating costs, taking into account the remote location, and also to restore a soil with good agronomic quality. So not only regarding the contamination, but also regarding other parameters to bring a treated soil that is in the end suitable for cultivation. So in fact, soil is more than just a composition, a chemical composition. It's a really complex combination of characteristics, chemical, physical, and biological characteristics. So we have to take into account several of these parameters to restore the good quality of a soil suitable for cultivation. What I wanted to point in this slide is that, for example, the combination of chemical composition and the texture leads to the formation of the clay-humus complex, which is a particle of soil made of clay and humus, and that is really important for life in the soil, because it's really a good exchange. It allows the exchanges between the soil and, for example, the plants, and also the microorganisms and stuff. So it's really important to have these kinds of particles into the soil, and you can only have these kind of particles if you have the right amount of organic matter and clay. So this is one example of the complex combination that happens in the soil. So to monitor the test we have done with phytoremediation and bioremediation, we monitored not only classical parameters such as the hydrocarbon content or the pH or even the texture, but also the nutrient contents, the organic matter, the TEC, and also the biological parameters such as the microbiology, the nematodes, and of course the development of the plants we have planted onto the phytopiles. So we have monitored several parameters, both qualitative and, for example, with the growth stage, and also quantitative with a specific analysis, for example, the omega-3. So into this test, we have several factors to be studied. So we wanted to compare the phytoremediation and the bioremediation. So one of the modality was or bioremediation or phytoremediation. We also wanted to determine the best conditions for the treatment. So we tested two factors with the amount of polluted soil regarding to the arable soil, and also the addition of lime to correct the pH a little bit. So, so we ended up with 12 modalities and also control plots, which were arable soil planted with the same species as onto the piles, and also a pile of contaminated soil, but without any treatment. So you can see here an aerial photography of the platform of the test, and the idea was really to know at the end of the treatment what would be the residual pollution, what would be the duration of the remediation, the cost, etc. So to select our species for the phytoremediation, we used really an agronomical approach. We started with species that have proven to be efficient for the remediation of hydrocarbons using a desk study, using existing bibliography. And then we narrowed a we narrowed down our selection using different criteria. For example, the organization of the trials, where we had only 2 or 3 years and not 10 or 20. So we couldn't use trees, for example, but more plants that we chose to be perennial to avoid to seed them every year. We also wanted to be adapted to the climatic and pedoclimatic conditions of the site. We wanted a complementarity of roots systems because to go through the piles, we wanted a species with a tapping root that goes really deep into the ground, but we also wanted the top layers to be really well colonized by roots. So we also chose a fasciculate root system. In the end, we selected 2 cultivated species that are grown into the area by the local farmers, and that was both to have varieties really adapted to the local conditions, but we also wanted to count on references to manage the cover, the vegetation cover. So we chose Alfalfa and English Raygrass, and for those 2 species, you have references. You have references on how many seed you need to put on the ground, how much biomass you can expect, etc. So that was really interesting to have these references to manage the crop. And the other advantage of Alfalfa is its ability to fix atmospheric nitrogen. And this is interesting because doing that, we don't need anymore to add fertilizers to the crop in order to boost the development of the 2 species. So during the whole test, we followed really an agronomic approach, and we used agronomic tools. For example, to prepare the soil that was done by a local farmer with its own tool to prepare the top of the soil. Then for the plantation, we used the seeding density. We calculated seeding density using agronomic tools. For the start of to boost a little bit the growth of the crop, we applied NPK fertilizer at the beginning of the tests. So once again, we used agronomic tools to calculate the right amount of nitrogen and other nutrients to be applied. Then during the test, well, you should maintain and protect your crop or vegetation cover. To do so, we used no fertilization because of the alfalfa and no pesticide. That was a choice. But we had to act after, well, not against it. We have to act after extreme weather conditions. For example, right after the seeding, we had very heavy rains that washed away a lot of the seeds on the phytopiles. So we had to overseed at the next season. And during summer, on the other end, we had a period of drought. So we had to add water to irrigate a little bit the piles in order to maintain the cover, the vegetation cover. And finally, for the harvest, well, it was not really a harvest because we had no yield objective. We only wanted the biomass to develop and to be able to degrade the hydrocarbons. But to monitor the development of the plants, we mowed and weighted the aerial biomass of the vegetation cover. So in the end, after several months and even years of treatment, we could see a similar reduction of pollution into the biopiles and into the phytopiles. So no real difference on the limit concentration of the contaminants, and also about the kinetics, even if at first the biopiles were more effective than the phytopiles. But in the end, after several years, you can see no significant difference. In the rhizopiles, the decrease, well, the rhizopiles or the phytopiles, it's the same, it's just another name. So we could see a difference between the top layers of the pile and the deeper layers of the piles, because the roots didn't reach the deep layers of the piles. We expected that it would reach up to 1 meter, but in the end it reached only 60 centimeters for the alfalfa. So it led us to adjust a little bit the height of the piles for the real treatment. The piles will be 60 centimeters and not 1 meter. About the bacteria, we have seen an increasing trend both in the biomass and also in the activity. So an increasing trend, but slight. And we have also seen a seasonal variation with an activity that is higher during spring and summer. For the fungi, we have seen no significant evolution or difference between the rhizopile and the biopile. But the discussion we can have here is that we didn't focus really on the rhizosphere, which is really the very local surroundings of the roots. And it is there that the fungi, the bacteria, and the roots really have great exchanges, and where the life, the microbiological life is higher. So we didn't really focus on this really specific and local area into the piles. So maybe we missed something here. And finally, the very interesting part of this test is regarding the nematodes, because in fact it's an integrative bioindicator of the health of a soil, because it's really an ecosystem in itself, the soil, and the nematodes are really a class of living beings that cover a wide range of functions. For example, you have nematodes eating vegetation, you have nematodes eating bacteria, you have nematodes that eat other nematodes, etc. So really, this type of living beings are a good indicator and an integrative indicator of an ecosystem of the soil. So what we can see here in the graph is that, well, in the left bar, which is the control plot, you can see that there is a diversity of kind of nematodes. You have well, all different class of nematodes, whereas in the second bar, you have only one class of nematode, which means that the ecosystem is not so diverse and not so well functioning as in the control plots. And here you can see a real difference between the biopiles, so the second bar, and the phytopiles here in the third bar, because in the third bar you can see that we have restored somehow a functional, almost functional ecosystem. So this is really interesting. And about the plants, so we have followed a wide range of parameters. So I won't detail every parameter, but we have seen a coherent evolution for the quantitative and qualitative indicators we have monitored. And those indicators are correlated both with the hydrocarbon contents of the soil and with the lime content of the soil. And of course, the season plays a role here as well, because in spring and early summer and a little bit in autumn, the biomass grows quicker. So we have seen, for example, I wanted to present one indicator in particular, which is the omega-3. It's a stress indicator for plants. The higher the indicator is, the better the plant live in its environment, and the lesser it is, the more stressed the plant is. So you can see at the beginning of the trial here in the left hand side of the slide, that the control plot, which is on the right of the graph, is higher, significantly higher than the other piles, so that are all phytopiles. So, and you can see that after 40 months of treatment, the omega-3 indicators reaches the same level as the control plot, which tends to show that there is some adaptation of the plants to their environment, to maybe a level of contamination. Maybe it's also a sign that the roots grows deeper, and so they reach maybe some layers of the soil that are interesting for the growth. So in the end, it's really nice to see that the plants can cope with such a contamination. At the end of the test, we have seen an equilibrium between the two species we have planted, but we have also seen the implantation of wild species. For example, here we have spotted two wild species that came from outside, which are gramineas, and also a plant from the order of the Apiaceae. And also a good, well, this is interesting for biodiversity, even if you can't say that a vegetation cover with two species is really biodiverse. But where it is interesting, it's because it allows also a life for and a shelter for insects and small vertebrates, etc. So with this test, we have shown that phytoremediation can be an effective remediation technique. Of course, it implies some constraints and above all, you need time. But as regards to the techniques, you can very well use agronomic approaches and tools to perform this kind of remediation. So not only polluted sites approach, but also agronomic approaches. And you really need, as farmers do, to adapt to changing conditions to maintain the vegetation and the well-being of your vegetation cover. So there is an increase of biodiversity using this technique, especially into the soil with the nematodes, and we have seen that a whole ecosystem has been restored, and also a little bit for the macrofauna and for the plants at the surface, even if it's less evident. But finally, in the end, phytoremediation leaves a soil that has improved not only regarding to the contamination, to the contaminate content, but also that has improved regarding physical and biological parameters. So that's really interesting for a soil that is meant to be cultivated a little bit later. So a better balanced soil that has regained functions and that is suitable for cultivation. For future trials, we would like to study more in depth the rhizosphere, also the microbial diversity on the long run, because we haven't followed really the diversity, for example, of the bacterial community, only at the beginning, but not so much on the long run, only on targeted genes. And we would like also to make inventories about the wild biodiversity, to see how this kind of techniques also benefits to unexpected biodiversity on the plot. And another idea to improve the techniques was to design a more complex combination of plants to improve the resilience of the vegetation cover to hazards, and also maybe to take advantage of local species or indigenous species that are already adapted to stressful conditions of soil. That's it for me. Thank you for your attention.
Thank you very much, Julie. There is no question in the chat now. In fact, unfortunately, we are late. So I propose for the planning for the program to go to the Japanese knotweed now. But is there a question for you? I think that at the end of the program, the workshop, we will have time to go to your eventual question. So until now, in the part 2, you could see the importance of biodiversity, to have a lot of plants, but sometimes it's not a good idea to have some species, which are the invasive species. And now we are going to another topic, which is the Japanese knotweed that we don't really want. And I propose the presentation of 3 people. With Pierre Dangis, working at SPAC as a biologist botanist, and Paul Bardos, that you have already listened at the beginning of the workshop, and Davy Leland, which is the director of Japanese Knotweed Control Limited company. So you can start the presentation. Thank you.
Okay, thank you, Marie. Hello, everyone. So I'm going to present to you in a few minutes the current situation in the Walloon region concerning the Japanese knotweed. This is a plant, and this is a plant considered as an invasive alien species. Oops, what a strange name. What is that? Invasive alien species are animals and plants that are introduced accidentally or deliberately into a natural environment where they are not normally found, and therefore cause serious negative consequences for their new environment. They even represent a major threat to native plant and animals in Europe, and so for the biodiversity. On the Walloon territory, the management of these exotic plants, as they are often called, is ensured by a specific service, the CIEI, in French, Cellule Interdépartementale des Espèces Invasives, or in English, the Interdepartmental Invasive Special Unit, which applies strictly the European rules, and sometime even go further. We will see why a bit later. Its actions are published in a comprehensive general guide that provide guidance on what to do when invasive species are discovered. These European rules are included in a specific regulation, as you can see here, entered into force on the 1st January 2015. And the core of this regulation is the list of invasive alien species of union concern. And you know what? Asian Knotweeds are not included in this list of alien species. And this is why the CIEI go further than the EU regulation and support the management measure for this plant. Concretely, actions are implemented at the Walloon level to further spread of these invasive alien plants and to reduce locally the damage they cause. And these actions can be found not only in the guide I was speaking, but also in two regulatory texts. The first one is a circular of the Walloon government dedicated on invasive alien plants. It prohibits all planting of Asian knotweed and recommends a series of measures to control the management of the clumps. The second technical text is the Land Management Reference Guide developed by our laboratory of reference in Wallonia under the law on soil management and traceability. It provides a range of measures to adequately treat contaminated land with Asian knotweeds. Frankly, there is no miracle solutions to eliminate an invasive plant population effortlessly. These species are very difficult to destroy due to their high vegetative propagation capacity. And some intervention may even lead to boosting them rather than eliminating them. Fortunately, there are techniques to limit their development or to eradicate them locally. For Japanese knotweeds, they are 10 and they are grouped into 3 general families. The first one is early eradication. This is simply the action to be taken very early in the development of the plant. So I think to uprooting, for example. The second family can be summarized as localized elimination. As the name suggests, it refers to use heavy methods to destroy an adult plant. I think to crushing, deep burial, earthwork, and evacuation of the contaminated land. And the first family is based on attenuation. Attenuation, I mean methods that will tie the plant to the point of exhaustion. So, for example, repeated grubbing, repeating grazing or mowing, tarpaulin cover. This is some example. There is even a technique that involves injecting herbicide directly into the stem. And the choice of these techniques depends on the objective pursued, but also on the means available and the local constraints. And in its guide, the CIEI has developed a decision tree to help us choose the most appropriate techniques. They are available into the form of fact sheets and on the website listed here. To finish, note that Japanese knotweed is an excellent source of resveratrol. What is that? It's a powerful antioxidant found notably in grapes. And Japanese knotweed contained high concentration of trans resveratrol, the active form of the compound which is the most useful for the body. So knotweed is quickly becoming the preferred source of resveratrol for pharmaceutical industry. And in Wallonia, a research project is underway with the CELABOR. This is a private laboratory, and also ICEP. This is our laboratory of reference in Wallonia, in order to optimize the extraction of this product. But I don't know, frankly, I don't know the actual status of this research. So this is end my presentation. Paul, the floor is yours.
Thanks, Pierre. It'll be Richard, aka David, who goes next, because his talk fits yours very well.
Okay.
Good afternoon, everybody.
I hear you well.
Okay, excellent. Yes, so David's actually on holiday this week, so I'm his business partner, so I will be just doing this brief presentation for you about Japanese knotweed in the UK. So just as a brief introduction and history to cover over Pierre's points, it was brought over by the Victorians in the 1800s as an ornamental plant, and there were, I believe, 4 specimens that were actually brought over, all female species, and that is essentially what we have in the UK from those specimens. Just to give you an idea of what the plant actually looks like, early season growth. So generally March, April time, you will get the budding.
Richard, we're not seeing your slides.
Sorry, guys.
Do you want me to put them up and you just tell me to change them?
Yeah, you can do, Paul. I seem to be having a bit of technical.
Oh. I'll do that. Bear with. Are they up, Richard?
Yeah, thank you.
Where do you want me to go?
So if you go a couple of slides in. So yeah, so as I said, brought in by the Victorians in the 1800s, and the specimens that were brought over. You keep going, Paul. This is essentially just to give you an idea of what the plant looks like in situ. Early in the season, the budded growth will show, and then the you can just pause it there because I think it's rolling through, Paul.
Hang on. Okay.
Yeah. So the early growth will show the buds, and those will produce this year's growth. It will grow anything up to 3 meters in height. The slide there that shows the dead growth, which is obviously end of season, and then the two slides with the two photographs with the rhizome on it. We call it the carrot test. It's very, very distinctive when you excavate the soil, where you can actually see the rhizome in the soil.
I'm not sure why it's doing this, Richard, sorry.
Yeah, it's the way David set it up. It's just making me speak quicker. So you can see when you use a ditching bucket, you can actually see where the rhizome is. It allows us to actually excavate on a much more specific scale rather than actually do to just do a uniform excavated area. And you can see the actual rhizome there in the soil. So why is it a problem? It obviously outgrows native plants in the UK and obviously across Europe, as Pierre has mentioned. You can see there in the photographs the issues that it causes to drainage and to structures of a wall. And one of Paul's favourite slides, you can see it here growing within a property. That's actually grown in somebody's kitchen. Those are two separate properties. You can see there the spread across the UK from 1900 in Kew Gardens and then out across. And there's now, we believe, a recorded instance of Japanese knotweed within every 10k area of the UK. Cost of invasives, this is all invasives, not just Japanese knotweed. The Olympic site was £70 million. The market from the DEFRA figures there from 2010 is 165 million, so a significant amount of money. You pause it on there, Paul, for a sec.
I'm trying to work out, okay, I got it.
Legislation, one of the things that obviously is slightly different in the UK is the amount of legislation that we have, starting with the Wildlife and Countryside Act. All sorts of things were brought in, waste management licensing regulations in 1994 and the environmental protection regulations, duty of care, which made a massive change to how we dealt with it, and also effectively started the industry that we have in the UK to this date. If you want to flick on, Paul. The bottom one there, the criminal law. So in 2014, the law was changed for antisocial behaviour. This effectively meant that if you have Japanese knotweed on your land, it's not against the law to have it, but it is a legal requirement for the landowner to do something about it. What was happening in the UK was that there were a lot of property sales, commercial and domestic, that were being held up because people were not dealing with incidents of Japanese knotweed. Roll over, Paul. Thank you. There was a landmark case which completed, I forget because of COVID, I think it was 2020 or 2019 with Network Rail in the UK, where they were forced to pay out for damage to property for two properties in South Wales. And this obviously is then developed into another industry for the legal perspectives. You roll over, Paul. Royal Institute Chartered Surveyors, because of the issues with the legal aspects of it, they have their residential property guidelines with Japanese knotweed, and we also have on the next slide the two others which effectively started the whole process. When we do domestic house sales in the UK, we have to show that we've not got Japanese knotweed within the property. So it's a legal requirement for the document to be filled in.
So, Richard, all house buyers have to do this?
Correct, yeah. On any domestic house sale, these forms have to be filled in by the house seller to say whether they are aware of and have Japanese knotweed on their property. The next slide shows the original code of practice, which was written by the Environment Agency back in the mid-90s. it became out of date, and INSA, who is the Invasive Non-Native Species Association in the UK, which is set up as a trade body to try and regulate the industry and make sure that processes are being followed properly, were asked by the Environment Agency to update that process. And myself and David, along with other peers within our industry, rewrote the guidebook, which is, I believe, available for download as well off their website. There are also newer methods, which is what Paul is going to explain to you now as the industry has developed in the UK. Thank you.
Thanks, Richard. Sorry you got plagued by technical problems.
All right. I hope it didn't spoil it for everybody.
Richard, can you see my slides okay?
Yeah.
Yes, it's okay.
Oh, so I can't start my video because the host has stopped it. Ingrid, did you catch me picking my nose or something? So what I want to move through now is where's the state of the art? I mean, the UK has obviously suffered a lot of economic and environmental consequences from Japanese knotweed. So where are we now, and how might this be of interest to SOILveR? As Richard and Pierre have already said, it's a widespread problem in the UK and in Wallonia, but it's actually widespread across Europe. And here are some pictures. So these are the first two actually from friends of mine. So there's Japanese knotweed in Austria. The one in the middle is the Netherlands. And the one at the bottom there is an example from the UK, where you can see the knotweed growing into somebody's gas supply meter. This is an informatic which Tao have put together. Richard and I collaborating with Tao about Japanese knotweed. So it's setting out the problem about the damage that it causes to infrastructure and to nature, and that it's extremely hard to treat. It sets out some of the current methods like containment or surface heating, or these biocontrols like mowing or grazing, and herbicide control and physical removal or excavation. The experience in the UK, unfortunately, is that things like containment don't really work unless you have a very specific type of geomembrane. Surface heating doesn't really work. Foliar controls of herbicides can work over time. Stem injection, as Pierre mentioned, is also quite an effective control method and more sustainable in the use of your herbicide. But the herbicide of choice is glyphosate, and that's already banned in some European countries and may be banned right across Europe because of concerns that its formulation is carcinogenic. There is a biocontrol method that's been released in the UK, some kind of an aphid, but that probably is a control that will weaken the spread of knotweed, but it won't actually eliminate it as a problem. So typically the control methods used in the UK are herbicides, or if you need an urgent solution, for example, you're siting a building, then it's physical removal, excavation and screening. Our interest, Tau, JKC and R3, is whether we can import some of the physical treatment methods from the remediation, contaminated land remediation world as a treatment method for Japanese knotweed. So in this example on the screen is an in situ thermal method. The consequences of Japanese knotweed just to repeat them, is damage to infrastructure, to habitat, and also to public amenity, for example, parks and gardens, homes, and private gardens. In the UK, these difficulties have actually made consequent difficulties in property transactions and mortgaging. So most householders, even private householders, let alone public landowners, find it difficult to finance a house move if they've got Japanese knotweed in their garden or on their property, or if the property they're interested in has Japanese knotweed. Another problem of knotweed is difficulty in the circular economy for soil. So in the Netherlands, in Flanders, and in the UK, you cannot move excavated soil under the various soil recycling schemes that exist there if it is contaminated with knotweed. Knotweed is a problem, is very prevalent on brownfields, on infrastructure such as railways and waterways, and urban areas. So the optimal treatments at the moment are stem injection, which, by the way, in Europe, you buy your stem injection from Richard and David, or by excavation and screening. And the excavated materials may be disposed of on site or may go off site. So there's a big opportunity really for the transfer of contaminated land remediation technologies if the costs are right. The problems with the solutions that we've got are that they are not effective. They require treatment over several years, for example, from herbicides. The knotweed itself is very resilient, and the plant can be shocked into dormancy. So the rhizome can remain in ground, not showing any growth for years, and then suddenly regrow at some point in the future, like a time bomb. Because of these problems, most of the vendors who are offering solutions to knotweed only give limited guarantees, and the guarantees are basically limited to them coming back to the site and respraying it. It's very difficult to understand the end point of the treatment. So to date, mostly this is done by regermination tests, but regermination tests can take weeks to months to give an answer. There are rapid tests that have been patented using viable stains, but they don't work very well. So because we can't determine treatment endpoint, this is a problem developing alternative non-herbicide treatment solutions. So what we're suggesting is an integrated solution with 5 components, and some of these are in place and some of them are not. So it would be great to apply physical control methods which can work within weeks or days in situ instead of years. Viability tests that work rapidly so you can validate outcomes. Some form of better guarantee for the treatment of a site, so that, for instance, if you've built something on the site, or you've got a garden on the site, you want more than the guarantee that someone's just going to come back and spray it again. You would like a guarantee to cover the fact that maybe you've got damage to your building or infrastructure because the knotweed treatment was incomplete. In an ideal world, we would be able to verify that treatment has taken place and that that's accepted by key authorities, for example, to allow a circular economy for excavated soil. And as we're already seeing from Pierre and Richard's presentation, it would be good if any new solutions can be included in technical guidance. So there's already an opportunity here, which is in situ remediation by thermal methods, or thermal methods for excavated soils. We that's Japanese Knotweed Control Limited and my company, R3, we have patented a new viability test, which is effective within 36 hours instead of weeks or months. Japanese Knotweed have an insurance. It is an infrastructure insurance from Lloyd's in London, and they've arranged that that's now available across Europe. Here are some things that we don't really have in the circle, which I think is an opportunity for a European project. I'm not just talking about something of benefit to our companies, but something where multiple technology providers could include their offerings and could be compared with some kind of an outcome that enables the treatment of this very difficult invasive knotweed to be verified and accepted by authorities, and some sort of platform for technical guidance that's subjective and independent. This is just to show you a little bit about the viability test that we have. This is a sampling protocol. It's based on a statistical distribution of the data that we've got from our viability tests so far. And what I want to draw your attention to is the little blue blob in the bottom right quadrant of this graph. So we have worked with a statistician to work out how we can deploy this viability test to be able to understand if sites have viable rhizomes left in them after treatment. And we have two areas here, a rather small area outlined in green. This small area is where the outcome is acceptable, that the number of viable rhizomes is below a threshold of a very small threshold, and we can show that with a statistical probability. Everything in the red outline is not acceptable. This is where we cannot show that the rhizomes have been rendered non-viable, where the probability is that there are viable rhizomes. And then in between, which is where this blue blob is a bit of a gray zone. We can't quite show it's acceptable, but it's not fully in the unacceptable area. And the blue square there, that's where the actual data point is. So the data point is in this gray zone, and the blue disc or shape around it is the 95% confidence limit. So in this case, we would say that you need to go back to do more sampling to determine whether or not the knotweed has been rendered non-viable on the site. Just to quickly mention, the test itself is based on conductivity measurement, so it's very simple and straightforward to do. So in terms of a research agenda, to set the scene, Japanese knotweed is an established biological contaminant. It is in the Netherlands, it's in Belgium, it's in France, it's in Germany, it's in the UK, it's in Ireland, and probably a number of other countries as well. So our story in the UK, you should take that as a lesson to show you just how quickly property markets can change. And they've changed as a result of this concern over knotweed. And this has had quite devastating social and economic consequences. For example, people can't move house, and it's taking a long time for that to be resolved. Our method of choice, our weapon of choice for dealing with knotweed is glyphosate, because excavation and removal is generally prohibitively expensive unless it's a development project, and the availability of glyphosate is already restricted in many member states, although stem injection may give us a slightly safer way of using it. So the research questions that I'd suggest are, can a herbicide like glyphosate ever be used sustainably? Is it some kind of an in situ treatment in that situation? Are there other in situ treatment options available? So I've mentioned thermal. Can we benchmark these options using viability test outcomes, looking at the time for treatment, the cost of treatment, looking at the sustainability of treatments for different kinds of contexts, operational sites, you know, like a railway, residential sites, or brownfields that's being developed. How then in practice, if we've got a treatment, would we validate and verify the treatments? And what guidance can we develop from this to offer to landowners, managers, and other stakeholders? So that was my last slide. I put it up because SOILveR's a research network. Clearly, Richard, David, and I have a very specific commercial interest in this, but we think it is also of wider interest as a research topic for SOILveR. So I think that's it from the three of us, Marie.
Okay, thank you very much for this presentation. And now there is no question yet in the chat, and we are a little late in the program, so I propose to discuss all together about the European Soil Strategy 2030, and then how we agree with this strategy for the topic of the biodiversity. If I look at the European strategy, it is written in the soil biodiversity for human, animal, and plant health that soil biodiversity is very important for human health, that the bioremediation and phytoremediation is needed, that the sustainable use of soil is to be updated, and there is a care to take care to invasive alien species. So I think that this afternoon we talk about all these topics, and I propose to you to react or to tell us what will be your message that you will want to give to the soil expert group, if you have a message. So if there are no direct reaction, I can propose to share my PowerPoint that I prepared, and we try to fill and to know if you agree with the proposal for the message that we would like to give to the soil expert group. Do you see the slide?
Yes, Marie.
Yes, okay. So I would like we can go to the different topics one by one, or if you want to say something, don't hesitate. For example, for the sustainable remediation and risk-based management, we can look at, for example, what is done and what is already experimented and what has to be improved, and etc. for the other topics. So for sustainable remediation and risk-based management, I think that this way of management is known today, is used in several countries, but there are, again, some people with a misunderstanding, thinking that we leave a pollution. So there is to improve for the communication to people with this. And I think it is a topic to stay with importance in the soil strategy. And to encourage other countries to use it.
Can I make a contribution for this one, as it was from my slide deck, Marie?
Yes.
So it is true that it's a fairly advanced discussion in the UK and the Netherlands, and there's a SURF been set up in France and in Italy. However, the actual uptake is still fairly limited. There are quite a number of larger organizations that are using it. For instance, WSP have a tool, TAO have a tool, Ramble have a tool, and they can apply these obviously on an international basis. But there's limited penetration for many organizations, particularly smaller organizations. So I wouldn't want to leave the audience with the view that this is already regular in the UK. It's increasingly common, but it is not widespread. So I think the real need is for case studies, for validation, and for reliably linking sustainability and cost effectiveness. And Valerie and Cecile have both commented about cost effectiveness. So I think the greatest contribution SOILveR could make would be that at some point in a year or two's time, we can actually say sustainability is worth X. Now, this is a very tough target, and there are people in the audience I know, like Jenny Norman, who've been trying to do this for years, but I think it's still an open question.
Okay. So the contribution of SOILveR could be to disseminate more information about the.
I think it would be very interesting if SOILveR was able to encourage a remediation project to look at sustainability in its decision making and then validate the outcomes and understand the economic value of those outcomes. I don't want to say too much more because I'd rather that Jenny said something, because she knows a lot about this subject.
Okay. But now I don't see the chat. So if people are writing in the chat, I can't see them.
No one has yet.
No, okay.
Despite me trying to encourage.
Okay. Encourage project with the sustainable topic. And for is there someone want to add something for the sustainable remediation and risk-based management? For example, in SPAC, we calculate the cost of the remediation if we would like to reach a threshold value, and if we don't do a specific risk assessment, and we are obliged to do a site-specific risk assessment, for example, to have a better cost. So it is for each site we have to remediate, we have to do this calculation of the cost effectiveness, and it is in the guide in Wallonia to do the remediation before doing the remediation. But it's just on the risk-based management. Okay, so we can go on the soil biodiversity contributes to human health. It is written in the European soil strategy. So I think that we could see with the first presentation in the part 2 that it works, that it is already done in experimental way in different countries. Because some people could imagine that it is not possible, and there is no real guide to do it. I think that we can add that there are different different manners to do it. Different methodologies to imagine how to improve the biodiversity.
Rainer, you can unmute yourself.
Yes, if I can speak up.
Yes.
Okay.
Thank you very much for allowing me to listen into these really interesting presentations regarding the soil biodiversity contributes to human health point. I was preparing a text for the CO pollution monitoring assessment, which is currently prepared for the first time. As you know, there's a monitoring part, outlook part, and so different elements that the Commission puts together. And on the particular, let's say, subchapter on soil pollution and human health, I tried to collect evidence on what happens to human health if some properties on soils, including soil biodiversity, are not in a proper condition. Or to look at facts, key facts that teach us that soil biodiversity needs to be promoted, maintained or promoted at a certain level in order to perform its full potentials. All this is unknown. It may be known in case studies, but the information transfer into the policy debate is not there. And it's super difficult to find key facts that teach us and guide us. And that also links to your overarching objective message to the expert group. The expert group is concerned with the challenge of filling a legal gap. Which information do you have to provide when it comes, for example, down to remediation, your previous point, to help or to raise the case that there is a policy gap that, let's say, a European initiative can take. And so the level of, especially when it comes down to risk-based management or risk-based procedures, risk assessments, there's so much knowledge there. An aggregation of this knowledge to a European level to see where things are solved and where things are not solved, where things need to be solved with certain means. That discussion can only be taken by key facts coming from people like you. And I find that very important, especially when it comes down to soil biodiversity and human health, where the knowledge transfer into the current policy closed discussion groups is really not provided. Thank you for allowing me to speak up.
Okay, and I would like to say if what I write for to improve is what you wanted to say. So to promote the biodiversity, you have evidences that it is important, the aggregation of knowledge and the policy to write and to implement. Maybe you could think that for soil biodiversity, if we want that people do it, they have to have maybe a common methodologies or a guide with different methodology to follow, because I think that it can be a threat for people. We have fear about this because they don't know how to do. Now we can go to the topic of the phytoremediation, which is written in the European Soil Strategy 2030. About the phytoremediation, we can say that what is done is that we are test in situ, which are working, but they are not common methodology to assess the phytoremediation as the right way. Do you think it is important to have a guide with different methodology of phytoremediation, or is it already existing? I don't know.
Well, I can speak for France only, but we selected phytoremediation based on the methodology about a polluted site that exists already in France. So the first studies and assessments on the fields are the same as other remediation techniques. Maybe we can add some parameters of interest for specific to phytoremediation, but basically the methodology to select the right technique exists. And then the limit I see today for phytoremediation, when we speak to our clients about phytoremediation, often they don't think it's really effective. So maybe SOILveR could help to gather references and cases to prove with an evidence that it works for certain kinds of contaminants and in certain conditions, but it works. And the other limit is the time constraint, because it takes time. So maybe there is something to do with the timing of the different studies and the regulatory studies to provide also to the authorities. So maybe these two things could be improved.
Okay, so sorry, du coup, I have a problem with point. Communication to stakeholders. And to improve, it was what was the? Sorry, I didn't take care about what you wanted to improve at the end of your sentence.
Communication to stakeholders, and also to gather and to provide more references and more cases. That prove
provide with references.
And the third thing was maybe to help with the timing. For example, when an industrial site closes, you have an administrative long time when you seek for authorization, when you deal with social problems and stuff, and this time could be used maybe to implement phytoremediation, whereas today we wait for the site to close, and then we do the remediation. But maybe it could be anticipated, but maybe there are some regulatory problems with that. I don't know.
Yes, I agree with you because of the duration of the phytoremediation. In fact, if we have a very large site, we anyway do the remediation for 1 year, 2 years. So sometimes it's not so long. Phytoremediation has a bad reputation of duration, but in fact, we can see that on a very big site, it could be a good way, a good choice.
Yeah.
So it could be how to select the right site for the phytoremediation. All sites are not good for the phytoremediation because they're a development project today, but sometimes it could be a good idea, and I think that most of people forget it.
Yeah, of course. Yeah.
I'm Valérie Baird from Ineris. I don't know if you listen to me.
Yes, yes.
Yes, okay. I just would like to add something about phytoremediation. I think you're right in a way when you said that tests are done in situ for phytoremediation, but it is just for some organics, some organic pollutants.
Okay.
It is not the case for all the organic pollutants, and it is not the case at all for inorganic pollutants. So as for the first point, we need case studies to prove and to get feedback from field sites.
Okay. So case studies are needed for other pollutants.
Yes.
There's one reaction in the chat.
Yes, tell me.
Paul had raised his hand. So first the chat. How to manage residual impact on human and environmental benefits linked to biodiversity already on site. I don't know if the person who has made this remark would like to put on the microphone and
yes, I can just explain a little better. It was something from the previously point. Soil biodiversity contribute to human health, and on polluted site, you have still some pollutants, not they're still there. And how you can make the balance between the pollutant already, the residual pollution, and the trees that are already there and they have to be preserved for biodiversity. So how you can make the balance, like it has been explained by Sweden, I think. I was thinking about the Swedish presentation. So how to do the choice between I let the soil inside or I take it off because the soil is polluted. How can I do the choice? I think we have no guidance. We have nothing.
No. Unfortunately, in Belgium, we have nothing about for this. It is for the future use. You think that if it is a forest and there is no project, it's not necessary to destroy everything, to do nothing at the end. But we can put this in to improve for the soil diversity to get a guide for
more knowledge. Yeah, we need to improve the knowledge on biodiversity to make the choice between biodiversity preservation and pollution excavation. I don't know, soil excavation. Yeah.
To be able to choose, to do the balance,
between benefits of biodiversity and
remediation, biodiversity,
and pollution impact.
Oui, pollution impact.
Or ecological benefits and pollution impact. Yeah. Okay, thank you.
Okay. And there is no, for soil biodiversity, there is no tool with quantitative risk, for example.
Yes, it's not taking into account the soil biodiversity is not, maybe how to take
risk, yes, risk assessment tool.
Risk assessment for soil biodiversity.
I see two raised hands, both from Paul. The first Paul is Paul Bardos. Could you unmute yourself, and then we go over to Paul Drenning.
Thank you very much, Ingrid. My input is for phytoremediation. So I'm part of the Horizon 2020 project called ICLA. And I expect this might be something that links to Richard Lord's interests as well, because he's in another phytoremediation project. We have some capacity to do a desk-based feasibility study for site owners on phytoremediation. Our interest is in linking electrokinetics and phytoremediation. So if SOILveR people have any interest in maybe a desk study that can perhaps then lead on to a new proposal to SOILveR. We could work with a site owner to do this desk study. So for instance, Valerie, if you've got an industry owner who's interested in a desk study, that then might trigger some research for you. We could do the desk study. We'd look at 3 areas in the desk study. We would look at technical fit, likely cost drivers, and a qualitative sustainability assessment. So that's just an offer I put on the table.
Okay. Okay, thank you very much, Paul.
Paul Drenning, can you unmute yourself?
Yes. Hello, my name is Paul Drenning. I'm a PhD student at Chalmers University in Sweden. I work closely with Jenny Norman, so I figured I got asked by Paul to speak a little bit, so I can speak a little bit to her experience. She's been working in Sweden for a very long time and addressing this general lack of innovation with alternative remediation techniques. And I think even still 95% of remediation is dig and dump, which is a huge issue. So I mean, I think one of the big things we've landed on recently, which kind of connects back to the theme of this seminar, is really to try to connect better remediation to improving or maintaining soil health or soil quality. And some of the interviews I've done with various experts in the field, they've even gone so far as to say that soil remediation in terms of managing contaminants is a completely different world than managing or trying to improve soil quality, which seems, very, I don't know, kind of brutally said and just kind of counterintuitive, especially when you see kind of the content of this seminar. And I think Julie's presentation was very clear and on the nose there. And so a lot of what we're working with phytoremediation in my project is to kind of connect these two better and also just find ways to communicate with different stakeholders and just raise knowledge to experts, because there's still a massive knowledge gap in Sweden in particular, and I can imagine it's very similar across different countries. So that'd be my 2 cents here to try to keep it short.
Okay, so I connect better. We connect better between remediation and human health.
I would say soil health instead of human health. I mean, human health is intuitive, of course, as well, but specifically soil health is what I meant here in this case.
Soil health. Okay. Yes. Sorry. Okay. We can go on if you agree with the invasive alien species. So in the European Soil Strategy, it is reckoned that the Commission will assess the risk for the future alien species. So for this, we can say that what is done, it is done that the list is already known, but there are some species to add. If I understood.
The problem is renewed by the European legislator, because if the Knotweed is not in the list, it is because they know that it's very difficult to control the plant. Okay. So we have actually a lot of technique to avoid the spread, to control invasive plants. Okay, we have it, and I speak for Wallonia, but also for other regions or country. But for the Japanese knotweed, we need to have specific techniques to fight about. So it's very important. And what I think is confirmed by the David and Paul presentation.
Don't hesitate if you want to add something or to correct what I have just written.
I just put something in the chat, Maurice, that you can cut
sorry,
and paste.
I cannot see because we are.
Okay, so I think that all of the countries on the other side of the channel, you need to look at what happened in the UK and make sure you don't follow the same path that we did with this social and economic consequences fear of the knotweed and its outcomes. So I agree with Pierre that Japanese knotweed needs to be in the invasives EC regulation. For SOILveR, I think the critical R&D need is to find is for you to support pilots of cost-effective and sustainable alternatives to glyphosate treatment or to excavation and disposal, because those are the only real tools we have at the moment, and glyphosate is about to be stopped, and excavation and disposal is a waste of soil. So I think those are that's the critical need is to support this piloting, because we're all struggling to support it. In the Netherlands, there were a group of local authorities. They were going to try and support testing of knotweed treatment, but they've not been able to make it happen. This is a real gap. Somebody who will pilot new treatments for knotweed, which are sustainable and not based on herbicides or disposal.
Paul, it's worth mentioning at this point, I know that you've obviously said about the fact that you don't want to go down the UK route and soil to landfill is a waste, but there are methods, including screening, that can dramatically reduce that, which are things that should be looked at in the EU.
I think that there's a lot of know-how from the UK because of our work, and particularly yours and David's work, that could be readily transferred if in some kind of guidance. Yes, I agree with you, Richard.
Knowledge, good knowledge in UK, but the remediation is limited to excavation.
As to herbicides or remediation, effective, that's not entirely true, because there are some effective geomembranes now as well, but it is a limited repertoire, and the repertoire is about to be made smaller because glyphosate will be banned in many countries, and we also want to encourage a circular economy for soil.
Okay. And do you think there's something else to add?
I pass back to Pierre now.
Yeah, Pierre. Okay. So if there's no other thing to add, I think it's a good summary of the discussion of today and a good conclusion for this workshop. And I don't know, Ingrid, who is to end the meeting?
Well, that's you, I think.
Okay. Okay, sorry. So I stopped the up. I go back.
Yeah.
Okay. Going back. So thank you for this workshop, for the workshop. Thank you very much for the involvement and the presentation, which were very clear. I didn't know a lot of biodiversity this morning, and this afternoon I know a lot of things. So thank you very much. And we think that all these elements could help the European strategy to raise. So thank you very much.